all of our trig functions. We got graph 6 of them, so I have an example of each from your study guide. And so we're going to look at each particular type of graph. And what we're going to start first off, we're going to start with how we learned them. We're going to start with sine. Now, when we're starting with sine, we need to go back and think about the trig properties or the trig attributes that we've needed. And the way that we've always started for all trig functions is first off, we start with the amplitude. A reminder that the amplitude is the absolute value of the value multiplied by our sine function. So we have 2 times sine, so we're going to take the absolute value of 2, so our amplitude is going to be 2. After we find our amplitude, we're going to look for the period now. Remember that period is 2 pi over b, and b is the value that is being multiplied by our x or our theta, in case there's a theta. And so if it's by itself, we're going to pretend that it's an understood 1 there, so it's going to be 1 times x. So that means this will just be 2 pi over 1, which is 2 pi. Now the next thing we're going to find is our quarter period. The reason we're finding these quarter periods is to help us label the graph. And the quarter periods can be found by taking the period and dividing it by 4 parts, which is going to be 2 pi over 4, but that simplifies. We always want to simplify to 2 or to pi over 2. From there, we're going to next look at our phase shift. To find phase shift, we're just going to take whatever is inside the parentheses. So right here, whatever's inside here, which is x minus pi, and we're going to solve for x. So to solve for x, I add pi to both sides, and I get x is equal to pi. And the last thing I'm going to look at is there a vertical shift? And again, a vertical shift just tells me that I'm moving my graph up, and it's by the value that's outside, which is going to be 1. Now, these attributes, guys, they'll give you either 1/3 credit or half credit, depending on the problem. And so if you can find these, you'll be golden. And essentially, the way we find these is applicable for everything else. The next thing that we need to do is look at our 5 key points. Now, these 5 key points are our key x values. And these x values are great for us because they're going to help us label our graph. Now, for sine, cosine, cosecant, secant, and cotangent, all phase shifts will start in the beginning. Meaning that whatever my phase shift is here, whatever that phase shift is, that means that's going to be my starting value. So my phase shift is at pi, and then what I'm going to do now is add a quarter period. Now, we said the quarter period was pi over 2. Now, the way that we add pi and pi over 2 is first you got to find a common denominator. So what denominator can we get from pi? Well, I can do 2 because that's essentially multiplying by the value of 2 over 2, which is 1. So that'll give me, I'm adding the next value to get 3/2. And then from there, I'm just going to continue to add pi over 2. So that'll be 3/2, 4 pi over 2, 5 pi over 2, and 6 pi over 2. Now from here, can I simplify anything? That's a question we're always going to ask ourselves. And you can. This 4 pi over 2 simplifies just 2 pi. And then this 3 pi over 2 would simplify to 3 pi. Now basically what this phase shift does is after we find these points, we're essentially calling our line of scrimmage, which is essentially this line right here, our line of scrimmage, our starting point. So I'm going to label this graph starting at pi, because that's our phase shift. And then every time I go over a dash mark, or I could do 2 or 3, it doesn't really matter how, I'm going to call it 3 pi over 2, and then 2 pi, and then 5 pi over 2, and then 3 pi. I realize I'm running out of space, so on the next problem, I'll move my line of scrimmage, so then I can have a little bit more space. And so with sine, we got the x values, now let's find the y values. For the y values, we always start with the vertical shift. So the vertical shift we determine to be 1. And then the upper and lower bound we find by adding and subtracting the amplitude. So that's going to be adding 2 to get 3 and subtracting to get 1. The reason that we do this is because on this axis here, right there, this axis, we can label this 1 rather than letting it be 0. Because if we do that, it'll make it a little bit easier to graph. So I'm going to call this 1, and then I'm going up 2 to call this 3. and then down 2 to call this -1. And now we're like 2/3 of the way there, guys. So now for sine, we're going to start. Sine will always start at the x-intercept. And then every time we go over a quarter period, we ride the roller coaster. So sine naturally goes up first. So I go up and then down, down, and then up. And that's essentially creating my sine graph. It's nice and curvy, and all it is 5 points. We're just focusing on drawing one period. And again, it's just kind of keeping it as is. It's all about the labels. So that's for sine. Now for cosine, I'm not going to go into as much description. Detail. So first off, we got to find amplitude, which is going to be 3, based off the number times the cosine. The second thing that we have to do is period. So period is again 2 pi over that b value. In this case, b is 2. So that'll give us pi. Our quarter period is going to be taking that pi and then dividing it into 4 parts. From there, we'll look for the phase shift, which the phase shift is going to be setting that 2x minus pi equal to 0. And so I'm going to add pi on both sides to get 2x over pi, and then divide both sides by 2 to get pi over 2. Finally, last but not least, do we have a vertical shift? In this case we do. It's -4. Now, again, for those 5 key values, what we're going to do is start with the phase shift. So I had the phase shift in the beginning, and we determined the phase shift to be pi over 2. Now, the phase shift is pi over 2, and then my quarter period is pi over 4, so that means every time I'm increasing, I'm adding pi over 4. What I'm going to do is essentially take pi over 2 and then add that pi over 4. I got to find a common denominator. Well, to find that common denominator, all I have to do is multiply by 2 over 2, because that's essentially that same value, and that'll be 2 pi over 2 over 4 plus pi over 4, which would give me 3 pi over 4. Now this 3 pi over 4, all that's giving me is the next value. It's not giving me I'm increasing by 3 pi over 4 each time. We're still going to increase by that pi over 4. So then that would give me 4 pi over 4, 5 pi over 4, and 6 pi over 4. And then from there, we need to simplify. And sorry for the atrocity of the handwriting. I'm just trying to do a good job with this pen that I have. So this 4 pi over 4 simplifies to just a regular pi, while the 3 pi over 4 will simplify to 3 pi over 2. So I see that you see the line right here. I'm going to move that. I'm just going to make my line of scrimmage, again, that starting line, I'm going to move it where it's right here. And the reason I'm doing that is just so that I have a little bit more room to write on, and a little bit more room to graph. And again, that line of scrimmage is where we start our phase shift. So the phase shift is going to be that pi over 2. Now what I'm going to do, I'm going to go every 2 tick marks. The reason I'm doing that is because this is a small screen and I can't really write as much. You can still do every tick mark if you want, but it's just more convenient for me to write it spaced out. So this will mean that 3 pi over 4 will be represented by this tick mark. Here I'll have pi, and then here will be 5 pi over 4, and then 3 pi over 2. And so that, again, now we're looking at cosine. Cosine's a little bit different. Cosine, we either start at the top or the bottom. Now, in order to find the top and bottom, we got to find our 3 values. So I do know that -4 right here is going to be my starting value of, like, right here. So this line, I can't even draw it. Here we go. This line here, all the way across, that's going to be our -4 here, that line right there. So -4 is this line. And then my amplitude was 3, so I'm going to go up 3 tick marks, and that's going to be -1. And then I'm going to go down 3 tick marks to get -7. And again, that's just taking those 3 values of -4, -1, and -7. Those are our key y values. So I've gotten everything kind of labeled now. So my up, my down, and my middle. Now let's start graphing. Now to graph it, cosine always starts at the top or the bottom, never the middle. And then we're locked in. We're going to ride the roller coaster, so we're going to go down till we reach the bottom of our amplitude, known as the trough, and then we'll increase till we repeat to back where we were. So notice that we completed one period, which is the point which we repeat ourselves. And for cosine, again, it's just that nice kind of wavy line. Make sure that you're curving on both of those. So that's for cosine. We've done sine, we've done cosine. Let's look at those reciprocal functions of both of those. So let's first, we just did cosine, so let's do secant. Now secant, what we're going to look at is everything the same, but when you look at a reciprocal function, it helps to write down, hey, what's the reciprocal? In this case, it's cosine. And the reason I do that is just know that when I'm thinking about, okay, how am I graphing this parent function? What does that look like? That's what I'm aiming for. So here I have my amplitude. Amplitude is taking the absolute value of 2, because that's that leading value. Then I'm going to take the period. Period's just going to be 2 pi, because there's x by itself, which will help my quarter period to be pi over 2. From there, we're going to take and look for our phase shift, and that phase shift is just setting x plus pi equal to 0 and then solving for x to get negative pi. And then the vertical shift is going to be adding 9 in the end. So if I was looking at those 3 key y values, I know I usually start with x, but I want to just do the y values while they're in my mind. 9 would be the first vertical shift, and then I'd go up 2, so that would be up 11, and then down 7. Now notice that there's no way that these numbers could fit on this graph. That's another reason why I normally make this line represent my vertical shift, and the line that goes up and down represent my horizontal. I think I said that backwards. This would represent horizontal shift, and then this would represent my vertical shift. Sorry. So back to where we were. That's all I'm doing is I'm labeling this as 9, and then I'm going up 2 to 11, and then down 2 to 7. Now, with cosine, we're going to continue on. We're going to get our 5 points. Our 5 points are our key x values. We always start with the phase shift unless it's tangent. And the phase shift, we're starting at negative pi. And our quarter period is pi over 2. So how do we add negative pi and pi over 2? Well, we got to find that common denominator. So to find the common denominator, I'm going to multiply this by 2 over 2 to get negative 2 pi over 2 plus pi over 2. When you add these two, that's going to be negative pi over 2. Then we'll have 0, then we'll have pi over 2, and then we'll have pi. Now, something that you're allowed to do, you can make the center line that I made right here, you can make that here. You can make it 0. And so if you like 0 there, go ahead and do that. I just do this because it's just easier to start with my phase shift. So that way when I start labeling, I can label this as negative pi, and then negative pi over 2, and then 0, and then pi, then pi over 2, and pi. So from here, I'm going to start labeling cosine. If I'm graphing cosine, I start at the top, unless if there's a negative, I would start at the bottom. Then every period, I'm riding the roller coaster. Now here's the difference. Rather than connecting all the dots for cosine, what we're going to do for secant, wherever you see an x-intercept, you're going to draw an asymptote there. And I mean, essentially, it would repeat the process going on forever. I know I did one in the last one. That's just force of habit. And then wherever you see a peak or a trough, a min or a max, you're going to draw a nice little U there. And that's going to be our secant graph. And I just need to go through that point, and that's for secant. And sine or cosecant is done very similarly. So